I think also I'm conscious of the fact that I'm in a foreign country and some of the tree names won't transfer. So I think that this tree is probably Devdar in Hindi. We know it as the Cedar. And I just wanted to start off with a little quote from the introduction to the book, which is a series of biographies of different species. One of my earliest memories is of a spectacular cedar of Lebanon near our home. That's not the one. One winter morning, we found it dead, its trunk and limbs strewn haphazardly and being sawn up. It had been struck by lightning. That was the first time I saw my father cry. I thought about the huge, heavy, beautiful thing that was hundreds of years old and that I had thought invincible and wasn't. And my father, who I had thought would always be in benign control of everything and wasn't. I recall my mother saying that there had been a whole world in that tree, and I remember puzzling over that. But my mother was right. Can you turn it down a bit? Thanks. My mother was right. There was a whole world in that tree, and so there is in every tree. So this is me with my father at the Royal Botanic Gardens Kew when I was about 6. And my father, you can see, is a typical immigrant to Britain, wearing a suit, even on a Saturday afternoon, to go to the Botanic Gardens. And one of the ways that my parents used to enthuse me and my brother with plants and to interest us in botany, which was his interest, was to take interesting plants and feed them to us. So this plant here, you see it quite often in Bombay, actually, in Mumbai. I don't know the local name, but it's called Dieffenbachia. And one of the things that my father did was feed me a little piece of this plant. Now, in England, when you buy this plant, it comes with health warnings saying, do not feed to children, animals, it's poisonous. And he fed me a piece of this plant for a very serious reason. And the reason is that in America, this plant has the common name dumb canes. And the reason it's called that is from the time of slavery, when this plant was used as a punishment for slaves who spoke out of turn. And it was a very sad story about slavery, but an interesting scientific one that my father told me about the very, very tiny crystals of calcium oxalate that are in the cells that enable the poison to go more easily through the membrane of the mouth. And when you take this plant, it kind of stops you from speaking for a while, which is probably a great thing if you're feeding it to a child in a tiny, tiny piece. And I often think, if only we could teach children this way. But that was a very important story for me to learn at the age of 6 or 7 through the science of a plant. And this one is probably more well known in this region of the world. This is an opium poppy. And I remember the effect it had as I licked it. The main effect, other than the slight numbing sensation on my tongue, was actually on my neighbours when I told them. And they didn't believe me. And my father said, oh, yeah, no, it's absolutely true. We fed him an opium poppy. And then over the years, I was in a lucky enough position to become sort of interested in trees by travelling, first as a documentary filmmaker and then on the board of the Royal Botanic Gardens at Kew. And I was amazed at the variety that there are of trees, the incredible wax palms that look so unlikely in Colombia. This one, obviously, everyone here is familiar with. But the sequoias, the quiver tree of Namibia, amazing variety just in trees. And if you wondered, by the way, what the definition of a tree is, the proper scientific definition of a tree is basically a thing that looks like a tree. A big woody stem and stuff on top. That is a tree. But I started wondering, from a tree's point of view, what are the things that trees need? And, anthropomorphizing, I started to think about, well, what do people need? And obviously the first thing that people need is water. And when I started looking at the way that trees get water all the way up to the very, very top of a tall tree, if you think about it from an engineering point of view, that's quite a difficult pumping problem. Water is heavy, and you need to get it very, very high up. And so those trees, there's a person, that's actually my wife at the bottom there. These trees are very, very tall. And it turns out that if you look at the very, very tallest trees of any species, whether present or in the fossil record, that all those trees are pretty much exactly the same height. So the very, very tallest examples of all the trees that have ever been on Earth are, and here are some others, the mountain ash of Australia or the Douglas fir, they're all about 120 meters, and that's the limit. And the limit is there because that's the limit that the trees can draw water up. And the reason that they can draw water up to that limit is something called tension cohesion theory, which I will test you on later. But if you go out in the rain with wearing a raincoat or with an umbrella, you see that the water forms little globules. And those little globules pulling itself together through something called cohesion, molecular cohesion. Oil doesn't do it as well, alcohol doesn't do it as well, petrol doesn't do it, but water does it really well. Right? It pulls itself into little globules. And that ability to pull itself together is what enables the water, when there's evaporation from the top of the tree, creating a little bit of vacuum, the column of water all the way down can move upwards. Right? And that's how the water gets up to the top of the tree. There comes a point, though, when the hydrogen and oxygen bonds in the water are just not strong enough to hold it together. And what I like about this is that anywhere in the universe where there is the same amount of gravity as we have, the trees will only be 120 meters high. Beyond that, the water can't hold itself together. I think that's neat. So the next thing that trees need is food. So here's a question. And it's a rhetorical question, so you don't actually have to call out the answer. But I want you to imagine that you're going to write the answer on a piece of paper. So the question is, here's a little seed. This is an acorn from an oak tree, which is very common in Britain. And here's charcoal, right? In between, we know that this grew into that. I think we can all agree. And this was made out of that. So the little seed weighs next to nothing. And the big bag of charcoal weighs an enormous amount. So where did all the stuff come from? Where did the mass, the weight of this, come from? Now, I know, because I've researched it with audiences in Britain, that 85% of a British audience will say it comes out of the ground. Right? I'm sure India's different, okay? 10% of the audience in the UK will say that it's from sunlight, that somehow sunlight is turned into heavy stuff. That would be amazing if it was true. I don't know about India, but in Europe, we don't have trucks driving around at night, filling in the holes that the trees have somehow sucked all the stuff out of the earth and made tree out of it. So it doesn't come from the nutrients in the soil, and it doesn't come from the sunlight. And the clue is, it comes out of the air. So all of the, oh, fantastic, 1,000 rupees. You'll pay me after, well, not me, you'll leave it with the organisers afterwards, thank you. So the carbon dioxide in the air, in this magic reaction called photosynthesis, combines with water that comes up through the roots and makes heavy stuff, right? The stuff that the tree is made of. And all of the mass of the bag of charcoal, which is all carbon, that's the carbon bit, all of it came out of the air. All right? So it came, and when you ask people, do they believe you? They'll say, no, because air doesn't weigh anything. I assure you that carbon dioxide gas in the air weighs a lot. Plants take in a lot of it, and they make stuff out of it. Okay, so this is a fantastic Scrabble word, right? If you play Scrabble. It's more than 7 letters, but there might be letters already on the board, madam. There's always one. Some things don't change across cultures, right? So this is an electron micrograph of the root of a tree. And you'll see that this is the tree root, the big kind of right-angular piece. And these little tiny filaments enable the tree to get some of the other bits and pieces that it needs, apart from the carbon dioxide that's coming through the leaves from the air. It needs some phosphorus, it needs some manganese, it needs some bits and pieces that come up through the soil. And the roots aren't actually terribly good at getting what they need. And they have this relationship with mycorrhizae, which are fungi that live in the soil. And I'll just read you a little bit about the fungi, and I think the name for a birch tree, which grows in northern Europe, is burge. Is that right? In fact, what I'm going to do is here we see how it grows into the root, this fungus. So it becomes, in a way, the same organism as the tree. And that's the birch tree. I don't know if you know it. Trees often develop symbiotic relationships with mycorrhizal fungi, which intermingle with their roots and extend beyond them in a huge web of minutely thin filaments. These networks are especially good at extracting nutrients from the soil, which they pass on in an easily digestible form. In return, the fungus receives sugars from the tree. Individual tree species cooperate with particular fungi, and the birch's life partner is Amanita muscaria, the fly agaric, whose fruiting bodies, the parts we see above ground, are scarlet with white sprinkles, the archetypal toadstools of every European fairy tale. Fly agarics contain a cocktail of mind-bending hallucinogens, around which all manner of shamanistic rituals have evolved, particularly among Siberian tribes and the Sami people of northern Finland and Sweden. So far, so human. Many cultures have psychedelic traditions. However, the fly agaric's psychoactive ingredients are not completely broken down in the body, but excreted. This offers the enticing possibility of intoxication and a spot of social bonding by drinking the pre-drugged urine of others. It's true that northern nights are especially long, and the forests might have been lacking in other excitement. However, one can't help wondering whether this practice was really as widespread as the few historic travellers who seem to be the common source of all the shamanistic pee-drinking stories were told and so eagerly reported. So I've just discovered a cultural difference between the UK and India, which is that in the UK everyone would be laughing uproariously at that, but clearly I'm in a foreign land, in a good way. So another thing that trees need is to defend themselves. They can't up sticks and run away when something wants to eat them. And when an insect or a herbivore sees this, they probably think lunch, right? So trees have developed an enormous number of ways to defend themselves, and they do that very effectively. So we have, in Madagascar, for example, this Pachypodium, incredibly sharp needle-like spines. We've got the Costa Rican Sandbox tree. Again, absolutely, you wouldn't want to climb one of those, I can tell you. And manchineel, I don't know if that, I can't remember where that's native. I think it does grow in some parts of southern India, horribly poisonous, almost every part of the tree. And then there are some which are more subtle. I don't know if you remember the story about the North Korean leader's brother who was murdered at an airport in Malaysia, I think. He was murdered using a two-part poison. That's what the sort of people who do poisoning for a living use. And you want to take two things which are essentially fairly benign, and when you mix them up, then they're dangerous. And this is a plant called cherry laurel, which has a two-part poison in it, so that both components are pretty benign, and when something chomps on them, it makes cyanide. Clever. This one you probably recognize. This is coffee. And the caffeine is there in plants as a defense mechanism. It's poisonous to many insects. But here's an interesting thing. We'll come on in a second to pollination and how plants need to attract insects. And you would think, wouldn't you, that you wouldn't put a poison inside nectar because you want the insect to come and drink it. But actually, many plants have evolved to put just a tiny touch of caffeine into into the nectar. And what happens is that the insects that visit, would you believe, in fantastic, beautiful, elegant experiments, have been shown that those insects, they can't even detect the level of caffeine that's there. It's below their threshold, but they have a better memory as a result of where the flowers are. Ask any student. Caffeine. This is clever. This has been eaten by a caterpillar, and you might think that that's some kind of poison there that's being exuded by the leaf in order to poison the caterpillar. But no, this is something that caterpillar doesn't really mind either way, but the predator of the caterpillar is fantastically attracted to this. So you attract the thing that is going to kill the thing that is eating you rather than killing it directly. Isn't that clever? And these trees are very common in the UK. This is, this is the sort of archetypal oak tree, the English oak. I'm sorry, I don't know the local name here. But in common with many other trees, they manufacture poisonous defense chemicals when they're under attack. And they detect that attack in a quite sophisticated way. So if I go up and scrunch a leaf in my hand, then it doesn't really do anything. But if something like an insect or some other herbivore takes a chomp out of the leaf, then it starts making a defense chemical that is rather expensive in terms of trees' resources to have there all the time, so that it starts making it just when it needs it. And the interesting thing is that chemical wafts around on the breeze and then triggers other trees nearby to start making the same chemical. So there's a kind of, like a herd, they defend themselves. Now, I mentioned mycorrhizae earlier on, those fungi that have a network underground. And it turns out that those chemicals can travel underground as well. And it takes a signal from here to the back of the room, that sort of distance, about a quarter of an hour to travel and alert other trees to start making defense chemicals. And those other trees might actually be of different species. So it's not quite as competitive out there as we used to think. And the other thing that happens through those mycorrhizae is that some of those sugars and so on that are coming from photosynthesis, they start traveling under the ground as well. And in a forest, you can find that 5 or 10% of all the products of photosynthesis are being transmitted underground between trees and of different species. So in Europe, when we have conifers which keep their leaves throughout winter, and deciduous trees that drop them, you find that at the beginning of the summer, when the conifers at the beginning of spring, when they have their leaves and the deciduous ones don't yet, then they'll shuffle some carbon towards the trees that need it, and back the other way at the end of the summer, when the deciduous trees are really efficient and the conifers aren't doing so well. Interesting sort of collaboration that goes on. So this is an image from the book. It has these wonderful illustrations, which are not by me, so I can say that they're wonderful. They're by a French artist called Lucille Clerc. And this is the kauri tree from New Zealand. And one of its defense mechanisms is to create a resin. There are lots of resinous trees in this country, not least sandalwood, of course. But the resin is there to poison and engulf insects. They get stuck in it, they get poisoned, they get put off. And particularly when the tree is damaged or slashed. This tree is amazing in terms of its history in New Zealand, that for thousands and thousands of years, the resin from these trees built up in layers just under the surface of the soil, just less than a meter underneath. And someone in the 19th century discovered that you could make the very best outdoor varnish for sheds, for trains, for ships, out of this resin. And 10,000 resin prospectors came to New Zealand, just like a gold rush. It was called the Resin Rush. And for decades, it was the biggest and most important export from New Zealand, more than wool, more than gold, more than anything else. And the whole of modern New Zealand infrastructure was built on the taxation money from resin. If in doubt, tax it. And the schools, the hospitals and everything else, and the clearance, unfortunately, of the forests. So that's the kauri tree. And then there's the Gutta-Percha from Malaysia. Everyone knows about rubber and the latex from rubber. But in the 19th century, the big thing, lots of entrepreneurial startup companies, fantastic investment in these sort of, everyone had an idea of what to do with the kind of the latex that the tree has evolved to defend itself with, for making these sort of curious rubber goods that were very, could withstand high temperature and you could mold into all sorts of shapes. And then someone discovered the most amazing use for this. Now, it sounds rather obscure, but this was a material, the only material in the 19th century that could be used for insulating submarine cables. Ooh, I hear you say. But the reason that's important is that it enabled countries to communicate with each other, because all the telephone calls that happened over the coming decades were along cables that were insulated with Gutta-Percha. The only use for Gutta-Percha now is for making dental implants. But in the 19th century, by the end of the 19th century, it started off with a sort of little route around the world, but by about 1910 or so, there were 250,000 miles of cable undersea around the world, all insulated with the latex from that tree. So I've noticed there are kids in the audience, which is going to be a bit... You might want to stick your fingers in their ears for this bit. This is a little piece about another resin that the tree has used to defend itself, which is a poisonous resin. You've probably heard of lacquer work. You know that. So these beautiful, beautiful objects are coated with layers and layers of lacquer, which is the sap of the, sometimes called the Japanese or the Chinese lacquer tree. And it's a polymer, so it's like a plastic, really. And I just want you to imagine what these objects would have been like to people who had never held plastic in their hands. Right? So these are waterproof, they had the properties of plastic, but years, centuries before plastic was ever made. And they have rather beautiful, beautiful foliage as well. But I don't want to talk about the just the beautiful bit. The creepiest historical use of the lacquer tree must be that of an obscure sect of ascetic northern Japanese monks intent on becoming Sakushinbutsu, or living Buddhas, as a route to enlightenment. The whole journey lasted several years and started with a slow reduction in the intake of food and an especially slimming diet of seeds, nuts, roots, and bark. With the intention of their corpses becoming a whole-body relic, the monks then gradually embalmed or mummified themselves by drinking urushi tea made from the sap of the lacquer tree. After becoming horribly dehydrated and dying slowly, their bodies were resistant to decay and too poisonous or unpleasant, even for maggots. 3 years after death, the monks' tombs were opened, and those few who had not decomposed were said to have achieved Buddhahood. Seen as assisted suicide, the practice was made illegal only in the late 19th century, and several Japanese temples still exhibit gruesomely well-preserved remains that are claimed to be those of self-mummified monks. Sweet dreams, everyone. So this is the alder tree, very, very common in Britain, and it tends to grow near water. And you find it in quite a lot in Europe, actually. And one of the reasons that it grows near water, 2 reasons, actually. One is that it has bacteria that it has a relationship with that live in the roots and can get some of the other things that it needs out of the soil, nitrogen particularly, out of the soil, even waterlogged soil. And the other thing is that it really resists rot. I mean, it's fantastically resistant to rot caused by bacteria and so on that can live in wet environments. And because it's so resistant to rot, the Venetians, they built their buildings in a lagoon, and those buildings are built on alderwood piles. So the piles were driven into the mud, and then they could put all sorts of stonework on top and everything else. And the Rialto Bridge there is still supported on the same pieces of alderwood from 500 years ago. Amazing. But that's not the end of the Alder story, because the the Venetians, as you know, it was an empire that they controlled the whole of the Mediterranean, really. They had an incredible military force. And the way that they exerted that force was through their navy. And the navy needed weaponry. And in order to make weaponry, you need two things. You need to smelt steel, for which they used alderwood charcoal, which has made the best charcoal at the time. And they needed to make gunpowder. And I don't know if you read military manuals every night, but it turns out that when the English army, now, the British army, need gunpowder, I don't know why they need gunpowder, there are other things, maybe they make fireworks. But when they need gunpowder, they specify alderwood gunpowder. Still, it makes the best gunpowder because it's the best charcoal. So here's an empire that literally was built on alderwood, and metaphorically as well, its power came from alderwood with the, so it's the architecture, the weapons, and the explosives to go in those weapons. Extraordinary. And at the height of the power of the Venetian Empire, they could turn out one ocean-going warship fully kitted out with all the weaponry and everything, one a day. Unbelievable. And they did that at a place called the Arsenale, which has given us the word arsenal in English. This is the whistling thorn, another great piece of defense. This is from Kenya, grows quite a lot in East Africa. And you can see perhaps that the thorn itself has a sort of hollow base. And that hollow base is the home for these incredibly aggressive ants. And if anything comes along to chomp on those, on that tree, not only do they get the thorn, but they get stung to bits by the ants. The ants are so aggressive, by the way, that when you have two trees that sway against each other, the two ant colonies fight to the death, to the very last ant. And it's called the whistling thorn because when the wind rushes through these thorns, it makes a kind of whistling noise. And interestingly, the local elephants and other big animals that wouldn't really worry about the thorns, but do worry about the ants, they have learned that that sound is worth keeping away from. So if you take a tape recorder and take a recording of the wind whistling through that, and then play it to the local elephants, they all trot away. There's an image from the book. So we have to talk about sex now, I'm afraid, which is going to be an interesting cross-cultural thing. So trees need to make more trees, okay? That's part of a tree's job. And there are two ways of doing this. One way is to have asexual reproduction, and the other one is sexual reproduction. If there were 15-year-olds here, they'd be shifting in their seats now. So with asexual reproduction, that works by basically taking suckers that are kind of shoots that come off near the roots, and that they can kind of plant themselves over there and keep growing. Okay. Now the advantage of that is it's really quick and easy. The disadvantage is that if all those trees there, which are part of one clump of aspen trees that do this, they're all clones. They're all identical twins of each other. Now the problem with that is that if one of them gets a disease, they're all susceptible, right? So one tree gets ill, you know that the same disease is going to affect all those trees. Aspens get around this by having quite a difference in genetic makeup from one clump to the next. Okay? And interestingly, actually, as an aside, probably the heaviest organism on Earth is one clump of aspens in Utah, which is, I think, about 8,000 tons. So one of the vulnerabilities, as I said, is to disease. And in Europe, I don't know, you might have heard of the elm trees and a disease called Dutch elm disease, which is unfortunately called Dutch elm disease because they just happened to find it and identify it in Holland, but it's nothing to do with the Netherlands. And the reason that all our elm trees in Britain died was because they were pretty much all clones of each other. And the reason they were all clones is because the Romans, when they invaded, they brought elm trees and spread them with cuttings all over the country because they wanted to grow vines up the elm trees, and that was the best thing, and the Romans really wanted to have wine. So unfortunately, all our elm trees pretty much succumbed. There's another way of making babies if you're a tree or a plant, and that is to have sexual reproduction. The advantage is that you get the genetic mix, right, which is terrific. So everything is a little bit different, so some of the things will survive if there's disease. But the trouble with that is that you're a plant, you can't move, but you've got to get your sex cells from the male parts of one plant to the female parts of another. So how are you going to do that? And the answer is with pollen. So pollen is the stuff that takes has the male sex cells in it, and it's got to find its way to the female parts of something else. And there are two ways of doing this. The first is the way that all the grasses, which are a lot of our food crops, do it. And that is, and there's the alder actually as well. And they make this pollen, they just chuck it all to the wind. Yeah, and it's everywhere. It's hugely biologically active, this stuff. And of course, causes lots of hay fever and allergies and asthma and so on. Surely there's a better way. But all these trees, this is willow, or willow, I think, in Hindi, hazel and walnut. These are all common trees in Europe. And you'll have the same thing here. Sycamore. See, every home should have a scanning electron microscope. The durian, which is common in Southeast Asia, in fact, I mean, you probably know the smell of it. There was a rather nicer story from Malaysia than murders and so on, where I think about a month ago, a building was evacuated because they thought there was a gas leak, and it turned out to be a durian in the air conditioning. And the durian smell of the actual fruit is there so that the seeds will get dispersed by animals once it's made the babies. But the flower itself is this, you can see that a bat is visiting that flower, that's at night. They're big, blousy flowers, the kind of thing that if it was a different material you might wear in your hair as a fascinator. But one of the reasons you might not want to wear it in your hair is because they smell like sour milk. And sour milk is incredibly attractive to bats, possibly not to people, but to bats. And they fly from 20 kilometers away to a durian tree. And of course, there's no need for color because it's at night and bats don't see the wavelengths of color that we do. But they can detect the shapes, big, blousy flowers, and the smell. That's the durian. So having made your babies, you need to make sure that the babies aren't going to compete with the mother tree, right? Because otherwise you've sort of shot yourself in the foot, as we say, to mix metaphors. So the kapok, spreads its seed to the wind. There are lots of things that do that. These things that you think wouldn't go anywhere, the cannonball tree of South America, actually there are sort of wild pigs that go and chomp on them and spread the seeds around. In Britain, we have these, people call them flying rats, they're not, but they're not. They're squirrels that are fantastically forgetful animals, so that they take hazelnuts or beech seeds or oak acorns, they bury them, they forget where they put them, and then those turn into trees, or at least some of them do. So yeah, I rather like the idea of a whole species depending on the forgetfulness of another species. And you've got these that are, very, they really stand out, pine nuts and blackberries and yew that stand out for, in Europe at least, for birds. And you'll have your own that are these kind of colours. Trees often make fruit that is highly laxative. And what you want is for an animal to eat the fruit and then deposit the seed somewhere else, and preferably with a little pile of fertilizer. And you don't really want the seeds to be inside the stomach of the animal for too long, because there are chemicals in there that will start digesting it. So you want to hurry it along. So the reason that things like figs are laxative is because the trees need to make sure that those seeds don't stay too long in an animal's stomach. The coconut is dispersed by water. And if you look at the genetic makeup of coconut trees, you can see that they've progressed around the world on the ocean currents. And you can see where they originated and where they've gone. And the interesting thing I find is that if you look at people's genetic makeup, you can see that those people have followed the same ocean currents. And then here is, in England, you would now get everyone going, hee hee. Obviously not here, we're much more grown up. This is the Coco De Mer, the heaviest seed in the world. One of these can weigh 30 kilograms, right? And the very last place you want to be is under a Coco De Mer tree, right? Because if that falls on your head, that's the end of you. Now, you would think, wouldn't you, that a seed like that is absolutely going to compete with the mother tree. It's not going to go anywhere. Nothing can carry something that's 30 kilos. And it's true, nothing can carry that. But what it does is that it'll fall here under the mother tree and then put out a kind of umbilical cord over to about where the door is over there, and then grow from there, using the nutrients from here for maybe a year or two. Amazing. These seeds, in the 18th century, nobody could quite work out where they came from, because they're not dispersed by water, but occasionally sailors would find one floating around. And for some reason that I can't imagine why, they were seen as an aphrodisiac. And they were literally the price of a king's ransom. One of these would cost about $100,000 in today's money. I mean, very, very expensive, and people weren't even allowed to own them unless you were royalty. The Coco De Mer. And this is the Sandbox tree it's native to Costa Rica. I took this picture in Madagascar. It's a bit of an invasive species. And one of the reasons that it invades so easily is that it's got this seed box here, which looks a little bit like a tangerine. And when it's ripe, it sort of goes to that kind of, that way up. And on a hot day, what happens is that the stresses inside build up because bits of it dry out faster than other bits. And so you get these stresses in there, and it's like a kind of big spring waiting to go off. And on a hot enough day, the thing explodes. And these seeds, which are about the size of one of those little silver coins you get in your change. Sorry, I don't know what the denomination is. They're about a centimetre or a centimetre and a half across, and about 2 millimetres or 3 millimetres thick. They come out like little frisbees, and they come out at about 220 kilometres an hour, right? You really don't want to be next to one of those. And when there's a whole lot going off, they sort of set each other off a bit. A huge bang each time. It sounds like a gun battle. Not that I really know what a gun battle sounds like, but it sounds very loud and lots of bangs. And they all go 50 meters, right, these seeds. And they come out at an angle which is absolutely perfectly arranged, taking into account wind resistance, to go the maximum possible distance. Amazing. Absolutely incredible. In the 19th century, there was an Austrian botanist who had one of those seeds in a glass bell jar. I don't need to tell you the rest of the story, do I? Nobody got hurt. That's good. But there wasn't much left of the bell jar. And this is another completely ridiculous tree. Now, in the United States, I made the mistake as an ex-engineer of saying, what an incredible piece of design that is. And they picked up the word design and thought, he doesn't believe in evolution. So I know that's not a problem here, but look at the way this plant has evolved. It's called the traveller's tree for two reasons. One is that if you drill a little hole into the bottom here and pop in a straw, you can drink water out of it. So it sort of collects water into the bottom of it. It's full of little wriggly things, and it's not very nice, but I guess it would help you survive. And the second reason it's called a traveller's tree is that this arrangement acts like a compass. So you can tell exactly which direction you are because they all point in the same way. That would be fantastic if only it were true. It's what all the textbooks say, And if you go to Madagascar and talk to the botanists, that's exactly what they tell you. They're very proud of it. And then you take Google Earth, and I say, look, this tree is pointing a different direction from that tree. So how does that work? And they go, oh, it's just an anomaly with Google. It's, so I wouldn't use it as a compass, even though all the books tell you that you can. But it's a member of the same family. Do you have these here? Yeah. Bird of paradise flower, we call it in England. But all the members of the Strelitzia group that include the traveller's tree and these, they have very similar seeds and very similar bracts, which are the bits that hold the flower and have the nectar in them and so on. And you can might be able to see that some of that structure is a bit similar to this thing. But there's an odd thing in that everywhere else in the world, other than Madagascar, the seeds are always bright orange, pretty much. Sometimes red, sometimes yellow, but pretty much bright orange. But in Madagascar, something's changed. And they're blue, and there are very, very, very few blue seeds in the world. And the reason is that the thing that is able to lever open those bracts and get the nectar, and the thing that is really attracted to blue colour is the ruffed lemur, permanently startled ruffed lemur. And the lemur is the one thing that is attracted to these blue seeds and can get at them. And Madagascar hived off from the rest of Africa about 90 million years ago, and these animals haven't evolved the red receptor in their eyes like we have and other primates have. So these ones only see blue and green. And because they can only see blue and green, the tree hasn't had to make the effort of all those sort of extra expenditure of chemicals and so on to make the other colours. So it's the blue. And if anything happens to that lemur, that tree can't have babies that will survive, right? Because it's the lemur that takes the seeds and distributes them around. And that's true of many, many species, right? Where there's something that the tree depends on for pollination or for spreading the seeds. And if anything should happen to that relationship, then the tree effectively will become extinct. And this is true of other plants as well. And that's why climate change matters so much. It's not just that the trees are under stress, but if the relationship changes, if something, so that the buds burst at a time of year when there isn't the right thing to eat them, or just changes by a few weeks, then the relationship isn't there and the tree can go extinct. So the other thing that trees need, I would say this, is trees need a bit of love and a bit of space. In southern Mumbai, it's really impressive to me, coming from a cold European city, to see just the amazing amount of tree cover, and that's a fantastic thing to be proud of, and has an enormous number of benefits to the city. Not least that you don't have to spend so much on air conditioning or treating the health problems that come from asthma and other things, because the trees are taking particulates out of the air. So, fantastic thing. So if I were to ask you to do something, it would be join some sort of movement. I don't know what you have in this country, but there will be things like the Worldwide Fund for Nature or things that, people who are planting or protecting trees. So please do that. And, obviously you'll all be buying the book downstairs, but that's fine. But people often ask me, actually, I'll be honest with you, someone once asked me, if I was a tree, what tree would I like to be? And this tree here is a relative of the aloe vera that you probably know from cosmetics. It's a much bigger tree aloe in Namibia. And I took this just a few months ago. And the reason I love it is not because it is thriving and beautifully sort of happy in this very, very arid environment where nothing pretty much will grow. That's impressive. But the reason I love it is because it's rather like in England if you have a Morris Minor, which is an old kind of car that everyone kind of smiles at. It's rather like having one of those. And the second thing that I like about it is that the surface of the tree, it's not doesn't show up so well in that. It has this sort of slightly powdery, whitish, powdery finish. So once you've laughed at it, or smiled at it, second thing you want to do is touch it. And so the idea of being a tree that people smile at and want to touch, I think that's the tree I'd like to be. Thank you.